Hey, my name's Dan Connor. I'm the owner of Bimmer Performance Center. The purpose of this short video is to highlight some of the key features of what makes this N52 cylinder head special. We're going to cover Vanos units, the operation of Valvetronic, the cam bearing wedges, intake runners, oil filter housing location, and a few other things. Let's start by talking about Valvetronic. And what is Valvetronic and what does it accomplish? Before we make our way to the intake side, where Valvetronic occurs, we need to talk about the exhaust side and the operation of the exhaust. Now I've loosened all the bolts that hold this camshaft to the cylinder head, and we're going to remove what BMW calls the bearing ledge. We're going to separate the two. And you can see we have here what BMW calls a hydroformed camshaft. Basically, it's a hollow steel rod, lightweight, and the cam lobes are slid on. They expand the camshaft to press against the lobes. Never seen one fail in the field. Accomplishes the job real well. We've even welded on this last lobe here. We TIG welded all the way around till it was glowing red, and then we took the cam and hit it hard down on our welding table, and there's zero movement out of this. So this process here gave us enough initiative where we are looking into options for regrinding the stock cam. Now, as far as operation goes, you have your hydraulic lifter, which sits inside the head. In the center of the hydraulic lifter is a port. Oil pressure comes here, expands the plunger, and keeps the follower riding against the lobe of the camshaft. It's really that simple. It's just a fulcrum effect. As the cam lobe comes around, it pushes down on the follower, which pushes down on the valve. As the follower comes back up, and on the other side, the hydraulic lifter keeps tension so it's not noisy operation and the cam banging against the follower here. And as the camshaft turns, it's making contact with the follower, and it's going to be pushing down on the valve here. And you can see I'll remove this, and I'll put this back here. And that's the whole magic and operation behind that. Very standard. What you do need to pay attention to, and we'll readdress this, are what looks like piston rings here on the end of the cam and where they ride on the bearing ledges. And we'll cover that when we talk about Vanos. Alright, moving over to the intake side. Alright, let's talk about the intake side and what's going on here where Valvetronic occurs. What we have is a intake camshaft. It's cast, unlike the hydroformed exhaust cam. We have the same style follower, the same style hydraulic lifter, the same style valve and valve spring with retainer. But what's different is what's in between the follower and the cam lobe. We have what BMW calls an intermediate lever, a retainer spring, and the eccentric cam. I'm going to rotate the cam here at minimum valve lift, and you can observe right now we're on base circle. We're coming up to max lift. The valve spring itself barely moved. Actually, it moved 0.18 millimeter at minimum lift, which is really not enough to even be seen by eye without putting a dial indicator on there. When the throttle is applied, I'm going to move it back to base circle here. I have a 4 millimeter Allen. I'm going to put on the back of the Valvetronic motor. The Valvetronic motor is splined to a gear on the eccentric cam, which is here. The eccentric cam has this half circle which makes contact with the intermediate lever. So let's go to wide open throttle. And you could see the lever has now moved to full max. When we turn the cam and we get to max lift, as I'm turning it and we're coming up, you can see the valve spring itself compressing. Right there, we just went from minimum lift, 0.18 millimeters, idle is 0.8 millimeter, to max lift, which is 9.9 millimeter. Essentially, through tuning, we can control valve lift, min and max, with the adjustment of this eccentric cam. So we've already shown that at idle, the valve itself is barely moving at all. Now, if we stop the lobe at max height on base circle against the intermediate lever, and next we move the eccentric shaft, this is the same action here as applying the accelerator in the vehicle. You can watch here. Watch, pay close attention to the valve and what the intermediate lever is going to do. So as we're turning the eccentric shaft, the intermediate lever is moving to max, and you can see the valve has opened to max lift here. And then when I turn, the tension gets more difficult because now we're actually compressing valve springs versus before it's just kind of, the only tension we had against it was fighting this retainer spring here. So as we come, we're on base circle, and now we're coming up to max valve lift. And you can see we just moved the intake valve 9.9 millimeters with it maxed out. We back off the throttle, and the eccentric shaft moves. You can see the valve lift returns all the way back to 0.8 millimeter. Alright, here's a shot of the spline drive and the eccentric cam working together. Right now we're at idle, and as we hit the throttle, we can go to wide open throttle. And this action here is what changes the ratio of the intermediate lever, the follower, and the half circle on the eccentric cam. Let's talk about Vanos. What is it? What does it do? And how does it operate? Vanos is a variable camshaft adjustment that on this N52 engine has 70 degrees of advancement or retard on the intake and 50 degrees of advancement or retard on the exhaust. This unit is a lot more compact than the model that it replaced, which was the M54 Mary engine. This, as you can see here, this is a trigger wheel, and it's not keyed, and the Vanos unit itself is not keyed. It could literally be put on any way. What holds it together is tension from this main bolt. This little hole here has a fixture for the special tool that sits here and here and has a pin that aligns this so the trigger wheel knows to tell us the DME what position the camshaft is in. Now if we take out this bolt, we take off the trigger wheel, we can remove the Vanos unit itself. It's pretty simple in design. If we remove these 4 screws and we look inside the Vanos unit, you can see where oil pressure can enter and move the gear separate to the relationship of where the crank is at. On the back of the Vanos unit, remove this plastic cover, you can see it's simplistic in design. It's sprung back, and these 4 holes here match up with the 4 holes here in the cam. Oil flow is controlled through 2 solenoids. You have your intake solenoid on the top, your exhaust solenoid on the bottom. Voltage is applied from the DME through this 2-pin connector. The plunger moves one of 2 ways, and sends oil pressure through the cylinder head along this passageway to the cam, through the cam to the gear, inside the gear for adjustment. What is important on both the exhaust and the intake cam is at the end of each cam there's what looks to be two piston rings here and here. These piston rings keep oil that comes through this port and through this port inside this channel that allows oil to flow out of here into each Vanos gear. Vehicles that don't do properly maintained oil changes, these two gears rings will cut into the bearing ledge and it allows oil to bleed past, which allows the pressure to drop, which will throw a fault because the Vanos did not reach its end stop position that was requested of it by the DME. The same can happen on the intake side. On the intake side, it's more severe. If it happens on the intake side, we can see the cap, and this one's fine. The rings have not dug grooves into it. But the bridge is all part of the casting of the cylinder head on the intake side. Once this damage occurs, there's nothing that can be replaced, and it requires a whole cylinder head replacement. So cylinder 3 right now is currently at max lift. We're going to leave cylinder 3 at max lift, and I'm going to reverse the Valvetronic motor, and you'll watch the intake valves close. So there's idle, 0.8 millimeter, and here's wide open throttle. Now, we've run this engine with no throttle body and no intake manifold. And the reason we can get away with that is because the fuel injector is in the cylinder head, not in the intake manifold. So that leaves it wide open for whatever type of intake manifold you want to run on the vehicle. In essence, that's Valvetronic in a nutshell. Now, what are the other key features of the cylinder head? Unlike the motor it replaced, that M as in Mary 54, the oil filter housing bolts to the cylinder head and also has coolant running through the oil filter housing, whereas on the M54 the oil filter housing bolted below the cylinder head to the side of the block. Another key feature of the cylinder head is that you notice there's no front cover on this motor. This cylinder head actually wraps around, so there's nothing here to leak. And it also builds strength in the cylinder head. The next step for us is we currently have this cylinder head at a machine shop, and it is being flow bench tested to see how many CFMs it's capable of flowing at what lift. And then we're going to port the cylinder head and then reflow bench test it to see what the cylinder head is actually capable of. And then at that point, that's going to give us the data we need to properly size the turbo for our up-and-coming turbo kit. That's Valvetronic in a nutshell. I hope you enjoyed this video. Feel free to make any comments or questions below. We'll do our best to answer it. Thank you.